Okay, welcome everybody. So my name is Steffen Mahler, product manager from Schneider-Kreuznach, and I will talk a little bit about liquid lenses. And Boris, thank you very much. This was the longest and most sophisticated introduction that I ever got for one of my presentations. Great job. So, where do I? Ah, here we are.
You're welcome, by the way.
Yeah, Schneider is a fairly old company with 110 years of experience, but we don't have enough time to talk too much about the history. So we have 330 employees worldwide with several subsidiaries in Asia and in the US. Mainly working with two business units. I'm from the business unit industry, where we do lenses, filters, and customized solutions for industrial applications. But now let's get to the interesting stuff, liquid lenses. So somebody asked for applications. Here are some typical applications in the industry where liquid lenses might be used. For example, package sorting. Every package has a different height and the lens has to be focused on the label. Bin picking. The robot is in different distances from the object, and so focusing is needed. The same as robot vision. Bottle inspection or other products which have different heights need a focusing, and even electronics inspection. Even if these are very small items, it makes a difference if the item is 2 millimeter or 5 millimeter high because of the low depth of field at close distances. So these are all fields where regularly refocusing need to be used. So solution is liquid lenses. I don't need to talk too much because Boris did the introduction. This is a simple means to really focus very, very fast into different distances once the depth of field is not enough to cover the whole depth of field. As Boris said, there are two major manufacturers, Optotune or VariOptic. Sorry, Victor, from VariOptic. In the end, we had to decide for Optotune because of the larger aperture. We have decided to use an element with 16 millimeter clear aperture for our lenses. I don't need to show this, but I can show this because this is a very nice, small animated GIF from Optotune, which shows how the liquid lens changes in this group. So let's get to real lenses with a liquid lens element. What were our design goals? As Boris already mentioned, most of the existing lenses which include a liquid lens element are covering sensor sizes up to 1.1 inch. And our goal was to get larger, at least 1.3 inches, because there are also many applications with larger sensors which would require a fast refocusing. We wanted to have an integrated design, so a fixed combination of prime lens and liquid lens element. We wanted to cover a large working distance range, and the idea was to have a performance which is really similar to a prime lens without liquid lens elements. The result were our two first lenses with a liquid lens element integrated, which is a 60 millimeter and an 80 millimeter lens. It was the combination of an existing prime lens with an Optotune lens element. And we are offering now 4 different versions. And the very nice thing that you see here is the large image circle. As I said, 1.1 inch is the largest on the market, which is about 17 to 18 millimeter image circle. These lenses are able to cover more, so much, much larger sensors. And even also, for instance, shorter line sensors like 28 millimeter line scan sensors are even covered with the 80 millimeter lens. It is not just putting both items together. It is definitely beneficial if a company like us or like Edmund does really the complete design of a lens, not only buying a single lens, buying a liquid lens and adapting it. It is always better if the optical company really does the full development, because the position of the liquid lens element can be optimized in respect to the prime lens. The prime lens can be tuned, so we can do small modifications in order to adapt it to the liquid lens element. And in this case, we also offer extension tubes in order to get very close also to the objects. So we can cover from infinity to, let's say, distances from 100 millimeter, 12 millimeter working distance if we use extension tubes. So we can really adapt it to many, many different applications. So now we get a little bit technical. I hope it doesn't confuse too much. What you see here are MTF curves. MTF curves characterize the performance of a lens in respect to sharpness and contrast. And the simple rule is, the higher the lines, the better the performance is. And what you see on the left is the nominal performance of the prime lens without liquid lens. In this case, it's the 60 millimeter. It covers an image circle of 62 millimeter, but we compared with the lens with the liquid lens element. So we are only looking here up to 12.5 millimeter half diagonal, so 25 millimeter diagonal. And if you compare the contrast here in a range of 50 to 40%, it's approximately the same as you have here with the lens with the liquid lens element included. And what does this mean? It means that in a first step, a liquid lens element must not reduce the performance of a prime lens. It is possible to achieve the same performance with and without the liquid lens element. I have to admit, this is a medium setting of the liquid lens element, so it's not driven to the extremes. But nevertheless, it's a very nice sign that we don't lose really any performance theoretically. What does it mean if we focus with the lens? This is shown here. You will see here, this is a nominal performance at infinity. That's the nominal performance at 1.8 meter, where no current is applied. And this is a performance at 1 meter. Okay, you see differences from the optimum setting to infinity or to the closer distance, but the difference is not really, really big. This means that it's possible, even with a liquid lens element, to keep the lens performance in a high range with a high performance over a large working distance range, and which is very important. Because if you have an application with changing a working distance, you don't want to sacrifice with lens performance or with system performance when you are changing the working distance. So this was all theoretical. You have heard from Boris that we are talking about liquid, that we are talking about gravity. And so what we, of course, did is that we designed the lenses theoretically, then we have built samples, and then we have measured the samples. We wanted to understand what's the difference between theoretical performance and practical performance. What you see here on the left side is the theoretical performance out of the optical design software. And on the right, this is the measured performance in our optical lab of the real built lens. As usual, you will always see a certain drop between theory and practical lens, either with a liquid lens element or without a liquid lens element. You typically won't never get the 100% ideal performance with a built lens. But what you see here is also that the difference is not too big. That's with open iris, and that's a stop down to f5.6, so just one step stopped down. You nearly get again the same performance practically as you have simulated with the design software. And I think this is a very interesting, very nice information, and a very positive sign about the liquid lens element. Boris spoke about it. What happens to orientation, the gravity effect? And yeah, this is really a very interesting effect. The performance, if the lens is orientated vertically, is typically higher than if it's orientated horizontally. This is because of the gravity effect. And what you see here, these are images taken from the Optotune website. Optotune has performed very, very nice tests with our lenses and have made a very nice test report, which they show. You see the link here, so you can read the complete report if you want on the Optotune website. And they have taken images of test patterns, and these are enlarged here in this case. And what you see here is, first, in vertical orientation, a test pattern from the center of the image and from the edge of the image with the open iris. So the most critical case in vertical orientation. You see a certain performance. This is I would say, a very good performance, and fits to the theoretical expectations that we had. If you do the same in horizontal orientation, you will see a certain drop down compared to the vertical orientation. And this is the effect of the gravity. This is what Boris described before. This is, let's say, as it is, coming from the liquid and the characteristics of the liquid, without considering that Optotune is just working on improvement, as also Boris described. But also here, sometimes you need a horizontal application and you have no other chance, you can't switch. There is still one option to get the system really well working. Stopping down. This looks a little bit different than before because this is now another working distance. This is even closer, but it shows really the effect what happens if you stop down the lens just by one stop. It stopped down from f4 to f5.6. You see very, very soft performance in the center. The edge is quite good. It had something to do with field curvature, and but I would say the center is not usable. But if you stop it down just by one stop, okay, you lose 50% of light, but very often this is not a problem. Then you really, really gain a lot of performance, and the lens is very, very well usable also in horizontal orientation. So keep this always in mind when you're working with a liquid lens element and you're suffering a little bit from weak performance. Stopping down the lens has a tremendous effect and might save the system solution. So we have not been any experts in liquid lenses, and this was also valid for myself. And when I played the first time, I had some hesitations. Oh, how difficult will it be to get it running? And I tell you, I was really, really surprised how simple it is. Optotune has a very good description of how to install the software, how to install the drivers, how to set everything up. And yeah, this picture shows in the end what you need. You need a computer, and that's in fact really my computer, my everyday workhorse. You need a camera with a cable, USB cable in this case. You need a lens with the liquid lens element. You need the Optotune controller with a cable, and that's it. The setup took me about 15 minutes and everything was done. I made some tests in my office and I really used a Post-it box and a map. This was about 20 centimeters from the camera, and this was about 3 meters from the camera. And it can show you what happened. This is the result of the setup. This is the slowest speed that I could set. and I tell you why I set a low speed, because the camera is a high resolution camera with a very slow frame rate. And so the limiting factor was definitely the camera speed. And this is a focusing from about 20 centimeter to about 3 meter, just with the liquid lens element. And I found this really, really fantastic. I like the performance very much. As you see, it's stopped down to f8. You get a really sharp picture in 20 centimeter distance, and you really get a good sharp picture in 3 meter distance. And this is only possible with this simple setting with such a liquid lens element. I have to thank Optotune for the support of this presentation, because as you have seen, some of the photos and graphs were taken also from the Optotune website. And in general, they are really great with support. So if you are working with liquid lenses, Optotune will be a great partner. And also, if we are not in direct contact actually with VariOptic, I'm sure also VariOptic would be a very, very good partner for you if you have applications with liquid lenses. As I said before, for our lenses, we have required the large aperture. Therefore, we decided to Optotune, but it's definitely not a waiting. I'm convinced VariOptic and Optotune, they are both doing a really, really great job with liquid lenses. Yeah, that's it. Thank you very much. I also would guess that I'm good in time, and I'm open for questions, and of course, later on also for the discussion.
Okay, thank you, Steffen. We have 2 questions. In order to use the liquid lenses, do we need a lens controller? I think you touched on that.
Yes. We need a lens controller. In this case that I have shown, this is a separate item, but Optotune is also offering now a liquid lens element with an integrated controller, so that you really only need one cable from the liquid lens element to the computer, and then you immediately can control the liquid lens element.
Okay, follow-up question was if your setup can be used for industrial use?
Of course, it can be used for industrial use. As I said, I simply set it on my desk, but of course you can use this in any industrial application, as I've shown in the beginning, as a parcel sorting, bin picking, or whatever. So let's say everywhere where you need to focus into different distances, and this can be done very easily by liquid lens elements. And as Boris said, the big advantage of the liquid lens element comparing to other options of focusing, every photographer is focusing and has autofocus and things like this, that's the speed and that's the reliability. I would not trust my photo camera doing 1 billion of different focus settings. With the liquid lens, I definitely would trust. And 1 billion sounds so much, but if you look at parcel sorting, for instance, the reader has to read, let's say, a parcel every second. So every second, a refocusing has to be done. And this sums up in a year already to many, many million of cycles. So there will be no mechanical solution working. Only liquid lens solutions will work over such a period.
Another question, maybe because it came up twice now, is it possible to control these lenses from Halcon or Cognex software?
Oh, this is something that I don't know. I would say that either Optotune or VariOptic would be good partners there.